graph the quadratic functions. Objective: by this lesson, you'll be able to graph a quadratic function by using its roots, intercepts, and to find the vertex. Complete the square to find the vertex, and find the vertex using the axis of symmetry. So this is a quadratic function, also known as parabola. How do we get this? Well, we just get a normal parabola, y equals x squared, and just type in numbers. This is the default way of getting any graph. So here's our table here. You plug -3 inside, you get -3 squared is 9, -2 squared is 4, and so on. You plot them, you get this parabola here. So that's what a parabola looks like. Let's talk about some of the key points, like down here. This point right there is called the vertex. A little more detail about that later. If you notice this, if you kind of draw a line right here that cuts the graph in half, this is called the axis of symmetry. Right, and then you notice these are both equally distant from each other, from the axis of symmetry. Okay, let's talk a little more in detail here. So again, we have the axis of symmetry. We have the vertex. Vertex is usually normally as h and k. The vertex, which is h and k, x value being h, y value being k. The axis of symmetry is actually on the x value. So the axis of symmetry, which cuts the graph to half, is its own equation. And that is x equals h. Whatever the h value in the vertex is, it's acting as axis of symmetry. We have the x and y intercepts. Well, we have the x-intercept right here and here. Remember the way you find the x-intercepts? You set y equal to 0. Likewise, if you want to find the y-intercept, you set x equal to 0. Like that. Now, when the parabola opens up, that right there is called the minimum value. So when the parabola looks like this right here is the minimum value, which is the y in the vertex, also known as k. Alright, so the vertex is h and k. The y value is a minimum when it's opening up. When the parabola opens down, we'll talk when that happens later on. We call this a maximum, relative maximum, and that is also the y value. X is where it happens at. So there's just some key things about a parabola. I should make note of our little thing down here, which is important. Your x-intercepts, right? These guys, where y equals 0, they're also known as roots. What that means is that they're solutions to the quadratic equation. Right. So if you set equal to 0, if you set your basic parabola quadratic formula equal to 0, and we get the solutions, they're called the roots, or x-intercepts. Now let's talk about some basic forms of quadratic equations. So we've seen the standard form, y equals ax squared plus bx plus c. Now you could rewrite it in different forms. So the first form you could do is if you factor it all. That's what's called factored form right here. If you notice our things are factored, when you have it in factor form, well, it's really easy to find the x-intercepts. So P and Q are your x-intercepts. You can see it right here, P and Q. Those are your x-intercepts. And now if you have the x-intercepts, you're trying to find the vertex or axis of symmetry, it's always halfway between. So that's what this is saying. Axis of symmetry is P plus Q divided by 2, or the x value in the vertex is P plus Q divided by 2. And finding axis of symmetry is actually a big thing that we're always going to ask you to find. We're almost always going to ask you to find the axis of symmetry, or find the x in the vertex, or just find the vertex in general. So it's good to know if you have this, if it's already factored for you and you have the x-intercepts, it's always halfway between. So very important. Super important. That's not a very good highlight, but that's important. The next one is what I'd like to say vertex form. Now there's two of them, they're kind of the same thing. So we'll look at this one first. This is vertex form. So this is already factored for you. It's put in vertex form for you. When it's in this form, it's really easy to find the vertex. It's inside opposite, outside follow. Inside x opposite, outside y follow. So in that case, it's really easy to find the vertexes. Inside opposite, outside follow. And since you have the vertex, you have the axis of symmetry. It's just the h value. So that's what it is right here. This is the exact same thing, just that your y value is nothing there. There's nothing there. So your vertex is going to be inside opposite h, and outside follow. Well, there's nothing there, so plus 0. And you get that. So that's why you see your vertex being h0, Again, you have the axis symmetry because you have the vertex already. So stuff like that. Okay, let's go a little more detail. Now, we talked about before how I talked a little bit before about how there's a min and max, and this is how you could tell when it's a min or max, when it opens up or down, and that is by looking at the a, the coefficient of the x squared term. If your a is positive, then you know your graph's gonna open up, and we have a local min. If your a is negative, then we know our graph's gonna open down, and we have a local max. Stuff like that. This is called concave up when it opens up, and it's called concave down when it opens down. Okay, so those are some of the basics. Let's start graphing this. So the first one here, we want to sketch the graph using axis intercepts, which are our x and y intercept. So you gotta find both of them. Remember, the way to find x intercept, you set x equal to 0, y equal to 0. The way you find the y intercept, you set x equal to 0. We don't find this axis, the state of the equation of the axis symmetry, which is also the x and vertex. Okay, so finding the x intercepts is super simple when it's in factor form like this. So we just set equal to 0. We find x intercepts. And we're going to get 2 times x plus 3, x minus 1. Right, all we have to do here is split it, and x is going to equal negative 3 and 1. Right, inside opposite, inside opposite. You're just solving, so you set each one equal to 0. Okay, y-intercept. In that case, we're going to set x equal to 0. So we're going to just plug in 0 essentially. So I get 2 times 3 times negative 1. Which equals negative 6. So my y-intercept is 0 and negative 6. That technically this is the negative 3, 0, and 1, 0. But most time when people are fine with just saying x equals 3 and x equals 1. Usually with y-intercept it might be a little more touchy. So it's like that. Axis symmetry. Now let's start graphing before I do axis symmetry. Just to show you what we have. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3. I have to go down to negative 6, 4, 5, 6. So something like that. Now my x-intercepts are negative 3 and 1, so here and here. My y-intercept is at negative 6 down there. Now, before I graph this, I already know it's opening up. You can tell by my intercepts, but also you can tell by the fact that my a is positive, so it should open up. If I want to find the axis symmetry, I think I cut this graph in half. What you want to do is find the average of your x-intercepts. Axis symmetry should always be halfway between these two. So axis symmetry. Listen, add up my two values, my x-intercepts, and divide by 2. So I get negative 2 divided by 2, which is negative 1. So there's my axis of symmetry. It's at negative 1. Like that. Now if I wanted to find the y-intercept, if I wanted to find the y value of the vertex, remember that's also the x in the vertex. All I have to do is plug it into the equation. Now they didn't tell me to find it, so I'm not going to. So we still graph this. So it looks something like this. I think we're mostly just doing a sketch, but that's kind of the idea. It's a positive a, so it opens up. That correlates with our y-intercept and our x-intercepts. There's axis symmetry. Next one's the same thing. Oh, it is a negative. So I'm gonna do this one quick. I won't find the y-intercept just because of the sake of time. Maybe I will. Let's just do this one real quick. So x-intercepts are 1 and 2, right? And it's that opposite. Set equal to 0 to solve, so 1 and 2. My y-intercept, which is substitute in 0. So I get negative 1 times negative 2, which is positive 2 times a negative 2 is a negative 4. Hope I did that correctly. Negative 1 minus 2 times negative 2. Yeah, negative 4. That's right. Axis symmetry. Halfway between my x-intercepts. Okay, I'd like to do that after I graph. I think it makes more sense. So here's 1, here's 2. And negative 4 is my y-intercept. Now keep in mind, this is a negative a, so it opens down. So actually my graph's going to look kind of like this. Like that. My axis symmetry should be right here. Remember, the way you find it is take the average of the x-intercepts. So it'll be 1 plus 2 divided by 2, which is 3 divided by 2, or 1.5. So look around halfway between these two. I get that. Now this next one, this is not in factored form. Well, you can kind of make it to play it as in factored form. This looks more like it's in vertex form, where this is plus 0, which makes my vertex negative 2 and 0. Like that. Now they want to find the x and y intercept. Y intercept is super simple. Just plug in 0 for x. Never changes. So I get y equals 1/2 0 plus 2 squared. 2 squared is 4, so 1/2 times 4, which is 2. So my y-intercept is at 0, 2. Now my x-intercept, a little more work in this case. So we're going to still set y equal to 0. So I'm going to get 0 equals 1/2 x plus 2 squared. So I actually got to solve this, since that's how you find it. That's how you solve it. So I'm going to multiply both sides by 1/2 to get rid of the 1/2. Times it by 2, times it by 2. So I get 0 equals x plus 2 squared. Right, square root it. 0 equals x plus 2. And x equals -2. So there's my x-intercept. And if I wanted to graph this thing, here's -2. My y is at 2 also. So there's the mark there. It is positive because my a is positive, so it opens up. So it's going to kind of like this. Alright, and I already have my axis symmetry from the vertex, -2. So I could have drawn that line first too. So something to that effect. Okay. Here's another one. Use a vertex, axis symmetry, and y-intercept to graph this. So again, this is another one in vertex form. So I like these. I already have the vertex. My vertex is inside opposite, outside follow. Boom. Right? Inside opposite, outside follow. There's my vertex. Now I want the axis symmetry. Well, axis symmetry is just the x in the vertex. So it's just going to be x equals -1. Right? Whatever the x in the vertex is, that's axis symmetry. Now, luckily for us, they don't want the x-intercept, which is set equal to 0. If they do want the y-intercept, and the y-intercept never changes, you just substitute in x equals 0. So it's going to be y equals -2 times 0 plus 1 squared plus 4. So -2 times 1 squared plus 4. Remember, always remember to do the power first, right? PEMDAS. Parentheses, exponents. There's no parentheses here, there's an exponent though. So it's 1 times 2, so it's -2 plus 4, which is 2. So my y-intercept is at 0, 2. And if I want to graph this, I'm going to start with our vertex, which is a -1, 4. So -1 and up 4. So right there-ish. And then let's draw the axis symmetry. So right, that x equals -1, so the axis of the vertex is line going straight down. Let's then cut our graph in half. My y-intercept is 0, 2. So right there. Remember, so all we're going to do is draw a parabola. It is a -2, so open down. So you can kind of see that here. It's going to open down like that. So whatever I do on one side, try to match on the other side. Now, I didn't have my x-intercepts to help guide me, but that's close enough. Okay. Let's talk about sketching x by completing the square. One way to go from standard form to vertex form is by completing the square. Just to remind you, when you complete a square, the whole idea is to make this a perfect square, so it's easy to factor. That's kind of the goal here. So let's remind ourselves how to do it. So steps. First thing we want to do is we want to isolate the x squared plus bx terms. So right here, we want to get these terms by themselves. So I'm just going to subtract 7 from both sides. So I'm going to get y minus 7 equals x squared minus 6x. And then we're going to do the complete the square step, the most important part. So we're going to complete the square. So that's where you get the middle term b divided by 2 and square it, and add this to both sides. In this case, I'm going to get my -6. I'm going to divide it by 2 and square it. So I'm going to get -3 squared, which is 9. So we're going to add 9 here, and we'll add 9 here. Then we'll simplify both sides. So this side gets me y plus 2, and this side just gets me what I have. Okay, step 3, so you want to factor the original side. Well, I would say the right hand side. You want to factor the side that's factorable. I'll put right hand side, but it's whatever side is factorable. So right here, you're going to factor it. Now, the key thing, it's super easy to factor. You made it so when you do the square step, it's always a thing before you square it. It's always this guy. So it's always going to be x plus whatever b over 2 squared is. Well, before you square it. So it's always whatever b over 2 is. So in this case, it's -3. That makes sense. -3 times -3 is 9. -3 plus -3 is -6. So it's always going to work out that way. So it's always going to be the thing before you square it. So it's going to be y plus 2 equals x minus 3 squared. So we factor this. And then lastly, solve for y. Get to move this back over. So I'll move this back over, and I get y equals x minus 3 squared minus 2. And that's in vertex form. And now it's super easy to find the vertex. It's inside opposite, outside follow, -32. So that's how you do it when the a is 1. If you notice, in this case, we didn't have a coefficient on our x. That's the easiest version of complete the square, but that's how you do it that way. So let's do this one. Write y equals x squared plus 4x plus 3 in vertex form by completing the square, hence sketch the graph of it by using the vertex. Now, I think up here I wrote somewhere that this is also, some books call it complete the square form, which I kind of find kind of ludicrous, but to each their own. I think most people would know this as vertex form because it's really easy to find vertex. Okay, so how are we going to do it though? We're going to complete the square. So remember, the way we complete the square, you want to get this guy by itself, so we're going to subtract 3 from both sides. So I get y minus 3 equals x squared plus 4x. Then we're going to complete the square. We're going to get that middle term. We're going to divide it by 2 and square it. We're going to get 4. We're going to add that to both sides. So now I have y plus 1 equals, and we're just going to factor this side. Now remember the trick, it's always the thing before you square it. So it's always this guy, x plus 2 squared. Right, and again, you could double check. 2 squared is 4, 2 plus 2 is 4. Perfect. Now we're going to get y by itself, so subtract 1, and I get y equals x plus 2 squared minus 1. If we complete the square, we got vertex form. Now he wants to graph this, so let's find the vertex. Inside opposite, outside follow. So you should get this, right? Inside opposite, outside follow. So there's my vertex. My symmetry would be -2. And they want to sketch this. Now, most of the time when we do this, it's just a sketch. Notice how it says sketching, not to like make points. Just trying to get the general idea of what the graph looks like. So it's like this. It's my x. It's my y. I'm just going to go -2 and -1. And then does it open up or down? No, look at your a. Right, my a here is 1. You don't see it, so it opens up. Again, we're just doing a quick sketch. So there we go. Okay, let's do a harder complete the square. In this case, there is an a in front. Now, how do we deal with when there's an a in front? Well, first, let me make all the ways a little easier by changing this number, this problem a little bit. I want to make this 4 right here into a 6. And you'll thank me later, I promise you. Now, I'll probably upload another video on the side that if you want to see a really ugly complete the square with the number in front done. But for our first time reviewing this, I just want to make it pretty straightforward. So, okay, how do we complete the square with the number in front? Well, actually, it kind of starts out the exact same way. If you look at the steps, there's only one new step we add here. So, first steps are the same. We're going to isolate the ax squared plus bx term. So we're going to get this. We're going to get rid of this one. We're going to subtract it from both sides. So I'm going to get y minus 1 equals 3x squared minus 6x. Remember, I changed the 4 to a 6 just to make our lives a little easier right now. And I'll upload another video of me doing the original problem. Okay, so here's where it changes. Complete the square only works when there's no a in front of the x squared. So you got to get rid of it. How do we get rid of it? We factor it. So step 2 is factor a from ax squared plus bx. Sometimes factoring is nice and easy, like the one I made up here, and sometimes it's pretty disgusting, like the one I originally had. And again, I'll do that in a separate video later. But no matter what happens, it always starts off the same way, which is I want to get rid of the 3, so I'm going to put the 3 on the outside, and we're going to factor it. And here's the dirty secret for factoring: it's always the same thing. You just divide. So I don't want the 3 there. I'm going to pull it out. That's how the way we factor by 3 is divide everything else by 3. So 3x squared divided by 3 is just x squared. -6 divided by 3 is just -2x. Let me erase that sign there. -2x. I'm going to leave a little space and you'll see why in a second. Now, if that wasn't saying it's nice, like a 4, it's the same thing. You just divide by 3, you get 4/3, and it gets ugly, but it does get possible. Anyway, so we get this. And that's the only new thing. Everything else stays the same, with the one little caveat. So rest, same. So that means we're going to complete the square. I get my middle term, my b term, divided by 2 and square it. And I get negative 1 squared, which is 1. So I'm going to add 1 here, and the only little caveat is this. I don't just add 1 on this side, because this is not just 1 added to this side. This is 1 times 3, because the 3 is on the outside getting multiplied by everything. So I actually got to add 3 to this side to keep it balanced. So it's plus 3 times 1, or just 3. So that's the only other caveat that's a little bit different. Is that right there. When you complete the square, if there's a number on the outside, it multiplies by the thing you added to this side. So now we simplify it. I get y plus 2 on that side. On this side I get 3. We're going to factor this. Now remember the trick. It's always a thing before you square it. So x minus 1 squared. And then we just move this guy over. Y equals 3 x minus 1 squared minus 2. And again, if I want to sketch this, my vertex is inside opposite, outside follow. So positive 1, negative 2. I'm just going to do a quick sketch. Here's my x, here's my y. Here's 1, and here's negative 2. Does it open up or down? That's a positive 3, it opens up. Like that. And there we go. Okay. So again, I'll do a normal one on the side again. Completing the square is not the only way you could get a general form into vertex form. There's actually a different way, and that way involves finding your axis of symmetry. And there's a formula for it, which is x equals negative b over 2a. And that is given to you on the formula sheet, so you will have access to that. This is probably the easiest way to go from standard form to vertex form. Now, where does that come from? It comes from the quadratic formula, the whole thing. They talk about it a little bit here. Go back later to watch it. So, in general, I give you a graphical quadratic equation like this, y equals ax squared plus bx. A couple key things. How do you find axis of symmetry? Easiest way to do it is by using the formula that is given to you in the formula sheet, x equals negative b over 2a. And then once you get to x value in the vertex, right, my vertex, remember axis of symmetry is also the x in the vertex. So if you have the x value, how do you find the y value that goes with it? You just substitute into the equation. So let's say this. Right, that just stands for basically plugging in your x value. So once you find the x value, plug in your x value to find the y value. If you want to find the y-intercept, right, you just set y equals 0, x equal to 0. Sorry about that. So it's not how I find the y-intercept. Set x equal to 0. If you want to find the x-intercept, you set y equal to 0. And then you got to solve this quadratic equation there, either by factoring, use a quadratic formula, and then you just graph what you found. So let's do one last example, doing all that together. That's right here. So, consider this. Let's find the axis of symmetry. So, again, we could do by completing the square if we want to. We're not going to do it this time. We're going to just use a formula to find axis of symmetry, which is x equals negative b over 2a. So, here's my a, here's my b, here's my c. Remember, those things are just the coefficients. A is 2, not 2x squared, just the 2. B is only 8, and c is negative 10. So, substitute it in. I get negative 8 over 2 times 2. So, negative 8 over 4, which is negative 4. 2. I can do math sometimes. So, there's my axis of symmetry. X equals 2. Negative 2. That's okay. So, there we go. Now let's go to this one, find the coordinates of the vertex. And again, I already know part of the vertex. Axis of symmetry is also the x on the vertex. So there we go, got that part. I need to find the y. And the easiest way to find the y is to substitute your x into the equation we have. That's always the case. If you have an x value, you want to find the y value, just plug it in. You have a y value, you want to find the x value, just plug it in. So I have y equals 2 times negative 2 squared plus 8 times negative 2 minus 10. So this is 4. 4 times 2 is 8. Plus negative 16 minus 10. It's negative 8 minus 10 is negative 18. So that's my, again, that's my y in the vertex. So there's my vertex, is negative 2 and negative 18. Find the axis intercepts. Oh, they want to find the x and y intercepts. Okay. I guess x-intercepts first, so I start writing x-intercepts. Remember the way you do this is that y equals 0. So we're going to get 0 equals 2x squared plus 8x minus 10. That kind of sucks. So we got to factor this. Or use quadratic formula if you want. Feel free to use quadratic formula. It is also in your formula sheet. I noticed they're all even, so I can divide everything by 2 and make this a little easier. So 0 equals x squared plus 4x minus 5. And now it's actually easy to factor. That is just going to be x plus 5. X minus 1 equals 0. Split it, x equals negative 5 and 1. So those are my x-intercepts. If I want to find the y-intercept, usually a lot easier. Y-intercept, you just set x equal to 0. Specifically when you have it in standard form, because when you plug in 0, you just get the constant, -10. I'll show the work here, but it's just going to be the constant. So y equals -10. Again, a lot of times they'll allow that, but sometimes they're a little picky and they want -10, 0. So there's my y-intercept. And now I want to sketch all this. So let's see, that's x, that's y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Man, I'm all the way down 16. Something like that. We'll set it to -16. Why did I put a mark on -16? My vertex is -2 and 18. I didn't go far enough. How about we just go, I'm like, hey, that's -18. Right, so there's -18, and we want -2 and -18. It's not going to be perfect, but they're the one I picked -18, not me. So down here is my vertex. My axis symmetry would also cut that in half. Let's find the x-intercepts, -5 and 1. So -5 is right here, and 1 is right there. And the y-intercept is -10, which I believe is around there. Well, let's say it's around there. Then we just connect it all. And there's my graph, and that's the lesson.